Hey folks, so this is example 5 from the section 1.3 notes on vector equations. It was the true false question. I left as a challenge for you to think about on your own. So the question was, is it true or false that there is a unique value of h so that the vector b, 10h, is in the span of v1 and v2? Okay, so a big part of this question and a big part of all of linear algebra is being able to translate a question like this into something that we can work with, right? I mean, by looking at this, it might not be immediately obvious how to start approaching this. So the first thing I would ask myself is, what does it mean for B to be in the span of V1, V2? Well, by definition, the span is the set of all linear combinations of V1 and V2. So it should mean that there are C1 and C2 weights for those vectors V, so that the linear combination of C1 V1 plus C2 V2 becomes V, right? So this again is for some weights C1 and C2 from the real numbers. Okay, so then the question is, are there C1 and C2 that make this B? But this is a vector equation, which we've learned how to solve using row reduction of an augmented matrix, right? So just to briefly remind you of that, right? That means we're looking for unknowns C1 and C2, so that C1 times this vector, 1, 1, 0, plus C2 times the second vector, 0, 1, 2, becomes the vector B, which is 1, 0, H. And we saw in class that in order to solve a vector equation like this, to solve for those unknown weights, C1 and C2, it is equivalent to row reducing the associated augmented matrix. So this is equivalent to row reducing the augmented matrix with columns, which are exactly these three vectors. Okay, so if I begin row reducing, I'll start by noticing my first pivot. Well, I can highlight it. Is this 1 in the top left corner? And so I can use that pivot to eliminate the 1 below it. So I'll do negative row 1 plus row 2. So 1 becomes a 0. The 0 doesn't affect this. And if I do negative 1 plus 0, that becomes negative 1. Okay. And I already have a 0 in the third row under that pivot. So that row reduction step is complete. And let me now move to my next pivot. So 0, 1, 0, 1, negative 1. So now I'm looking at the second one, which is a pivot. And I need to get a 0 below that, right? So in order to do that, I need to do a negative 2 times row 2, add it to row 3. Okay, so negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 1 is positive 2 plus h. Okay, that becomes h plus 2. And so yes, it's you know, not going to simplify more than that right now, but that's okay. And at this point, I am in echelon form, right? Not necessarily row reduced echelon form, but I'm in echelon form. And I can see from this point, I'm actually able to stop. I don't need to continue row reducing. Why not? Well, at this point, I can start thinking through the logic. So at this point, we know that this system is consistent if and only if h plus 2 is not a pivot position. Right? Because if h plus 2 is a pivot, that means the system is inconsistent, right? How do I know that? Well, remember, this right-hand side is really the augmented part of my matrix. And so I don't want to pivot in that last column. And so that is, to be consistent, we need h plus 2 to be 0. If it's anything other than 0, then I have an inconsistent system. If it is 0, then yeah, okay, then I can solve this system of equations. So that means h equals minus 2 is the only value which works. So taking this back to the original question, we see that this vector equation is solvable only when h is -2, which means b is in the span only when h is -2. So is it true that there's only one value of h? Yes, it is true that there's only a single value of h, so that this vector b is in the span of v1, v2. Okay, I hope this made sense. If there are questions, of course, please come to office hours or email me with anything that's unclear. Thank you.